Hello everyone, welcome back to the CSAT PYQ series. So next 5 questions are based on a common set of directions. I will be solving each question in a separate reel. So if you find this helpful, do check out the other parts as well. So let us first understand the directions and the answer options. Each question is followed by 2 statements and our task is to determine whether the given statements are sufficient to answer the question or not. So let us first understand the option. Option A states that only one statement is sufficient. Option B states that either statement alone is sufficient. Option C states that both statements together are sufficient. Option D states that even both statements together are not sufficient to answer the question. Now let us solve the question. The question goes like this. X receives 3 coins of different denominations 1, 2, 5, 10 and 20. If the total amount received by X is M, then does X receive a coin of denomination 5? So let us first understand the question. We have 5 coin denominations of 1, 2, 5, 10 and 20. X receives exactly 3 different coins and their total value is M. Now we have to determine whether one of these 3 coins is of rupees 5. Since we have 5 denominations and we have to choose 3 different coins, the total number of possible combinations is 5C3. This is equal to 10. Since there are only 10 combinations, let us list all of them. First, let us write the combinations in which rupees 5 is present. So, these combinations will be 5, 1, 2, 5, 1, 10, 5, 1, 20, 5, 2, 10, 5, 2, 20, 5, 10, 20. Now let's list all the combinations in which 5 is absent. So these combinations will be 1, 2, 10, 1, 2, 20, 1, 10, 20, 2, 10, 20. So we have listed all the 10 combinations. Now let us calculate the value of M for each combination. So M is the sum of all the coins. 5 plus 1 plus 2 gives us 8. This gives us 16. This gives us 26, 17, 27, 35, 13, 23, 31 and 32. Now that we have all the possible values of M, let us test the statements. M is not a prime number. So let's check the cases in which M is not a prime number. 8, 16, 26, 27, 35 and 32. Since 32 does not contain 5, statement 1 is not sufficient. Now let's check the statement 2. It says that the sum of digits of M is greater than 5. So sum of 8 is 8, 8 is greater than 5. 16 is 1 plus 6 is 7, 7 is greater than 5. 2 plus 6 is 8, 8 is greater than 5. 1 plus 7 is 8, 8 is greater than 5. 2 plus 7 is 9, 9 is greater than 5. 3 plus 5 is 8, 8 is greater than 5. In the second case, in which 5 is absent, 1 plus 3 is 4, 4 is lesser than 5. 23, 2 plus 3 is 5, 5 is not greater than 5. 3, 1, 3 plus 1 is 4, 4 is not greater than 5. 3 plus 2 is 5, 5 is not greater than 5. So we can see that in the cases in which the sum of digits of M is greater than 5, 5 denomination is present. Hence, statement 2 is sufficient. Therefore, statement 2 alone is sufficient and the correct answer is option A. The question goes like this. For 2 distinct real numbers x and y, which of them is bigger? So we are given 2 statements based on which we have to identify the correct answer option. So let us take this first statement. First statement states that x square is less than y, which is less than 1. So let us take 2 cases. Case 1, x is less than y. So let's take x equals to 0.5 and y equals to 0.6. So here the condition is satisfied since 0.25, which is x square, is less than 0.6, which is less than 1. So this condition is satisfied. Here x is less than y. Now let's take x greater than y. So let's take x greater than y. X will take as 0.9 and y will take as 0.85. So here x square will be 0.81, which is lesser than 0.85, which is less than 1. So here as well the condition is satisfied. So statement 1 is not sufficient to answer the question. Now let's take statement 2. So statement 2 states that y is less than root x, which is less than 1. So let's take 2 cases. First case, x is greater than y. So let's take x as 0.25 and y as 0.2. So root x will be 0.5. Here the condition is satisfied since 0.2 is less than 0.5, which is less than 1. So the condition is satisfied. Now let's take another case. In this, x is less than y. So let's take x as 0.25 and y as 0.4. Root x will be 0.5 and therefore 0.4, which is y, is less than 0.5, which is root x, and this is less than 1. So here also the condition is satisfied. So in both the cases the condition is satisfied. Therefore statement 2 is also not sufficient to determine which number is larger. Now let us combine both the statements together. So combining both statements 1 and 2, we get x square is less than y, which is less than root x, and this is less than 1. So let us take 2 cases. Case 1, x is less than y. So we are taking x as 0.25 and y as 0.4. So x square will become 0.0625. So this is less than 0.4 and this is less than root x, which is 0.5, and this is less than 1. So the condition is satisfied here. Hence x less than y satisfies the condition. Now let us take condition 2 in which x is greater than y. So we will take x as 0.25 and y as 0.2. Now x square will become 0.0625. So 0.0625 is less than 0.2, which is less than root x. Root x is 0.5 and this is less than 1. So in both the cases, the condition is satisfied. So even after using both the statements together, we still cannot determine which number is larger. Therefore, the correct option is option D. Even both statements together are not sufficient to answer the question. I would like to remind you that the questions like this can be time consuming. So in the paper, it is usually better to prioritize other questions and revisit tough questions only if time permits. The question goes like this. If x and y are integers, then is x even? We are given two statements based on which we have to identify the correct answer option. Before we begin, here's an important concept. The square of an integer has always the same odd even nature as the integer itself. In other words, square of an even integer will always be even and square of an odd integer will always be odd. Now let us evaluate the statements one by one. Statement 1 says that x square y square is even. So a product is even if at least one of its factor is even. So this means that at least one of x or y must be even. But we still cannot determine whether x is even. Therefore, statement 1 is not sufficient to answer whether x is even or not. Now let us move to the next statement. Statement 2 states that 1 plus x square plus y square is odd. This means that x square plus y square is even. This can be only possible if both x and y have the same parity. This means that x and y should have the same odd or even nature. So if both are even or if both are odd, this condition will be satisfied. But again, we cannot determine whether x is even. Therefore, statement 2 is also not sufficient. Now let us combine both these statements together. So from statement 1 we got that at least one of x and y must be even. And from statement 2 we got that both x and y are of the same odd even nature. That is, both are odd or both are even. So the only possibility that satisfies both these conditions is that if x and y are both even. So x is definitely even if both these statements are true. Therefore, both statements together are sufficient to answer the question. Hence the correct answer is option C. Now let me briefly explain the question first. We are given that x is a collection that contains only odd numbers and y is a collection that contains only even numbers. And every element of a collection T belongs to either x or to y. Our task is to determine whether every element of T belongs to y. That is, whether all the elements of T are even. So let us evaluate the statements given one by one. Now let us take statement 1. Statement 1 says that the sum of any two numbers belonging to T is even. So we already know that all the elements of T are either from x or from y. This means all the elements will be either odd or they will be all even. So this condition is always satisfied because even plus even will give us even number and odd plus odd will also give us even number. So we cannot determine from statement 1 whether all the elements of T are from y or all of them are even. So this statement is not sufficient. Now let us look at statement 2. Statement 2 states that if both P and Q are picked from T, then P minus 1 into Q is even. So P and Q are elements of T. They are either the elements from X or they are both from Y. This means they are both either odd or they are both even. So P minus 1 into Q will be always even because if P and Q are odd, then P minus 1 will become even and Q will become odd. So even into odd will give us even. And suppose if P and Q are even, so P minus 1 will become odd and Q will be even. So odd into even will also be even. So this condition is always satisfied. If all the elements of T are even, then also this condition is satisfied. And if all the elements of T are odd, then also this condition is satisfied. So statement 2 is not sufficient to answer the question. Now let us combine both the statements 1 and 2 together. From statement 1, T is either entirely odd or entirely even. Statement 2 is also satisfied in both the cases. So both possibilities still remain. Therefore, even after combining the statements, we cannot conclude that every element of T is even or every number of T is from Y. Hence, the correct answer is option D. This question cannot be answered even after using both the statements. So the question goes like this. If x, y and z are integers, each greater than 1, then is x a prime number? So we are given two statements based on which we have to identify the correct answer option. So we are given that x, y and z are integers that are greater than 1 and we have to determine whether x is a prime number. So let us evaluate the statements one by one. Statement 1 says that x y square is equal to 116. So let us do the prime factorization of 116. 116 is equal to 2 square into 29. So looking at xy square and 2 square into 29, it is clear that y square is equal to 2 square and x is equal to 29. Since 29 is a prime number, statement 1 alone is sufficient to answer whether x is a prime number or not. Now let us look at statement 2. Statement 2 says that xz is equal to 261. So let us do the prime factorization of 261. 261 is equal to 3 square into 29. So there can be many cases for x and z. X is equal to 9 and z is equal to 29. X is equal to 29 and z is equal to 9. X is equal to 3 and z is equal to 87. X is equal to 87 and z is equal to 3. Now, in some cases x is prime and in other cases x is not prime. Like in the first case x is not prime, in the second case it is prime, in the third case it is prime, in the fourth case it is not prime. So statement 2 is not sufficient to answer the question. Therefore the correct answer is option A. Statement 1 alone is sufficient while statement 2 alone is not sufficient to determine whether x is a prime number. If you found this video useful, please like, share and subscribe, and I'll see you tomorrow with another CSAT PYQ. Thank you.